Hello, my name is Rajesh Sundaresan. Somdatta Sinha asked me to tell a little bit about my background as well. So I am an electrical engineer by training, and my bachelor's was in communication engineering. Then subsequently, I have worked on this topic called information theory, which has quite a bit of connection with statistical physics and related topics. Then since I was in the industry for a few years where we were actually designing cell phones. So we designed what are now 3G modems, but that was about 13, 14 years back. So those modems are now being actively used. Then after that, I joined IISc, and in IISc, I've done a variety of things related to starting from communication engineering. So I did some of that as well. But then I have worked on a spectrum of topics ranging from applied probability to statistics, and some of it has actually gone into social sciences. And today you will see something on that side. So this talk is on reputation-based information design for inducing prosocial behavior. It's actually joint work with one of the postdocs at IISc by the name Alexander Reifers. So it's going to be a game. In the morning, I think you looked at morning and also during the exercises, you looked at analysis of games. One of the things that I will try to show here is how to model to come to a game. And later on, we'll do some equilibrium analysis as well. But the focus will be a little bit more on the modeling side. And it's about something that all of us would like to see, more prosocial behavior. Okay, so there are lots of activities that we do which are based on voluntarism. And these are things that we do which often go unrecognized. And yet, if you think about it, without our doing these, the fabric of our society is that much poorer. Okay? So here are many examples. We volunteer, many of the students here may have volunteered to run your hostel mess. If you're graduate students or if you're faculty, if you're scientists, you'd be reviewing papers. These are all voluntary activities. Maybe you generate content in Wikipedia. That's a voluntary activity as well. Perhaps you help in the running of a professional society. And for my area, IEEE is the one that we all participate in and help run. That's also a significant amount of drain on one's time. It's volunteering activity, and many of you will be doing something similar for your research community. Maybe organizing a summer school like this, which takes quite a bit of time away from the research that you would like to do. But there is you do see a benefit, but not for yourself, for others. And somehow you must like to do such things and derive happiness out of those. And so that's another prosocial activity that we would like to see happen. Running a Carnatic music club or any other music club in your institute. I say Carnatic music club because I participated in one such entity in IISc, and I know how difficult it is to do this while doing your research, and that's a prosocial activity. There are people that come to the concerts, listen to it, enjoy it, and then walk away. They are quite happy that they were able to listen to it, but the amount of background work that had gone into getting this, getting the funding for this, organizing the logistics for the singer, the instrumental people, and so on, to come and perform that day is a significant amount of background work that the audience doesn't get to see. So that's another such activity. Club cricket, another thing that I have been involved in. Here are a list of things that one has to do. And of course, there are those that after the mat has been unrolled, they come, they play, they practice, they leave. And then it's left to those who are more social or more pro-social oriented to do the other activities and get the club running. Going green by reducing electricity consumption, or going green by reducing fuel consumption. That's also something, using public transportation. That's also what I would call a prosocial behavior. Giving time and money. Those are all prosocial actions. Okay? And so these are examples. an individual volunteering time and effort towards this is actually engaged in prosocial behavior, and we would like to understand or model this particular activity. Okay, so if you look at a population of individuals, let's take maybe the bunch of reviewers that review for a particular transactions or a journal. You can actually see that the level of actions or level of if this is the level of prosociality, the more you are to the right, the greater the amount of time you're spending reviewing papers. You would actually see a distribution like this. There are many that will contribute a sort of median or middle range, but there are some exceptional people that spend a lot of time doing a lot of reviewing. And then, of course, there are those that do minimal reviewing. So you'll see this spectrum of people. And this is what nature is. This is how things are. And one would like to actually get people to move a little more on this side. So that's the goal of this particular talk. So what kind of methods can we do to get people to be more prosocial? So I like to think instead of PDFs, I like to think in terms of CDFs. And so here is, so for those who have not seen this is the level of prosocial action. And if I look at a point here, this fraction of people have prosocial action less than or equal to that value there. So that's the CDF that comes from this PDF. Okay, so what we would like to do is push this thing here. So for example, if you're the general secretary of your hostel, you would like more people to volunteer and take up volunteering activities. If you're the chair of your department, for those who are faculty, you would want more of your faculty members to spend time doing committee work. If you're, for example, the director of your institute, you'd like more people to come and help run the institute. If you're the prime minister of a nation, you'd like to get your citizens to be, let's say, better citizens. And these are the things that one would like to do. And what we mean by that is to move this a little to the right, get everybody to be more prosocial. Or in terms of the CDF, move this to the right. Okay, so here are some ways to do this. So for example, you can issue a diktat saying that thou shalt do this. Okay, so that's what I call external forces. So here is one such thing which has been very successful. It's called, it's a law, the Company Act of 2013, there was a modification of this act, which basically brought in this corporate social responsibility. What is corporate social responsibility? Every company which is making a profit has to pump in 2% of their profits towards activities of societal relevance. So I'll give you some examples. They must invest in poverty alleviation, education, gender equality, hunger, alleviation of hunger, and so on. So this is something that has happened, and it's been successful. I think India is one of the very few places which has this particular law, and it's one which has actually worked. I call this as an external force that's directing people towards more pro-social work. There is also this that some companies have. Every employee can spend 1 week a year as paid time off, which is sort of time to give. So you can go and volunteer and you'll be given vacation from your company for doing this. So I know that Cisco, which is a multinational company which has its offices in India as in other places, so they have this 1 week a year time to give. Okay. There is also this kind of thing that we often get, memo asking employees to take pledges that they should spend a certain number of hours towards certain pro-social activities. And some of these have worked and some of these have bombed. Okay? But these I call as external forces, and what we would like to do, though, is in order to have these things remain in a sustained way, we would like to see if this kind of a nudge which pushes people towards more pro-social actions, if it could be manufactured from within, okay, from within the network or within a social network. So for example, can we leverage the social network and human nature? And I'll I'll specifically indicate what I mean by human nature in the next few slides to get a more immediate effect. Some of these are very long term. So the corporate social responsibility took several years of planning and convincing. This is, of course, just one order, but it didn't work at all. Can we do something which is a little more sustained, and it can be something which will have an immediate effect? Okay, so that's what we would like to think about here. Okay, so if you look at this particular graph here, and so here is the level of pro-social actions. You look at how many papers scientists have reviewed, and you get a distribution like this. And you want to push it to the right, not many ideas come to mind. Okay, so how to increase is a puzzle when you just look at this particular PDF or the CDF. But if you think a little more about how this came about, then some ideas emerge, and that's what I'm going to speak about. That is, if you consider micromotives and how the above actions, these actions are kind of outcomes of these micromotives, then you'll be able to do a little better. So here is a model that I have. It's sort of a cynical view that even those who are giving a lot of time are actually optimizing something. They're doing for some pleasure. Okay, so what's this model? Okay, so agents, even those with very high levels of pro-social action, are actually optimizing a payoff. And so I'll come up with this model. So consider a population of individuals. This time we are not going to look at what their level of actions is and just say that, oh, this is how they're distributed. But instead what we will look at is an underlying sort of intrinsic motivation that they might have and how it is distributed. And so that's, let's say, a population of individuals with a certain intrinsic motivation. Let's take an agent I to have a certain intrinsic motivation, Wi, and the distribution of this intrinsic pro-sociality or intrinsic motivation levels has this particular or some distribution. Okay? And then based on this, and we'll see what this agent is optimizing, there is a certain outcome which is an agent's action. So when an agent is considering what action or what level of pro-sociality he should assume, he's actually trying to optimize certain things. For one, here is a payoff, and WIAI is one quantity that he is interested in. And if a person has a greater level of pro-sociality, that's this intrinsic motivation, then what would he choose? He would choose a higher action level. Okay? But then if we didn't have any other terms, then what this person would do is choose an A as large as possible. Okay? And that's ideal. But of course, every pro-social action comes with a cost. And I'll just choose a simple model for a cost. The cost is quadratic. The more pro-social you are, the more costly it is. Maybe you're spending more time. And in fact, we'll think of it as a convex function. So has convexity, etc., been treated in the... okay, so this is a function. How many of you are not familiar with the shape of this particular function? Okay, so everyone is familiar with it. So here is something that is increasing. So when you choose an action AI which is larger, you derive a larger payoff. But then there is a cost associated with it, and the cost is somewhat increasing. And it's increasing in a non-linear way. The more pro-social you want to become, the greater the cost. Okay, and here this is a simple model, and what each agent is actually trying to do is optimize the simple payoff. And what's the if an agent has a certain WI, what's the optimal action? It's just a simple derivative optimization that you can do here, and you'll get the answer, and I'll put that in the next slide. So here it is. So every agent is trying to maximize, so let me go over there. So every agent is trying to maximize this particular payoff, and he's trying to choose this action. Of course, he has been endowed with a certain intrinsic motivation, and this intrinsic motivation is WI, and that's the benefit that he gets, but then there is a cost. And when he optimizes it, the solution is actually quite simple. You take the first derivative, equate it to 0, and if you take the second derivative, it'll demonstrate to you that it's actually a minimum, and so the first derivative condition is what you should use, and it turns out that AI is equal to WI. Okay, that means the action level that the individual takes matches with the intrinsic motivation. Now, you actually see that we have sort of gotten back to our original action levels are matching with the WIs, but that's in our simple model here. But it's going to give us a powerful tool, and I'll get back to that. So here is the intrinsic motivation distribution. So this is the way in which people are endowed with this intrinsic motivation. There are some that are naturally here who have higher intrinsic motivation. You can anticipate that they're going to contribute more, and there are some who contribute less. So here is the CDF. But then it leads exactly in this simple model to an action profile which matches with the intrinsic prosociality, with the distribution of intrinsic prosociality. Okay. Now, I'll come back to what does it mean to have a larger W in yes? Right now, there is no difference between AI and WI. That's because in this model, I have chosen it in such a way, I have rigged it so that instead of thinking of AIs, you can think of WIs. And AIs are a perfect reflection of what the intrinsic motivation is in this model. In general, it could be different. It will depend on what the payoff function is, what the cost is, what the positive returns, what the cost is, etc. But I've chosen it just for illustration purpose to match perfectly with the intrinsic motive. So the actions will match the intrinsic motivation. Okay. So high intrinsic motivation makes a teacher, somebody who has a higher intrinsic motivation than me, for example, would make the teacher care about her students more than I would. Okay? Larger the W, the more care that student would take about his or her student. An institute Charlie cares more about his institute than me if he has a higher W, higher intrinsic motivation. And a reviewer R would do a better job on the review than me if he has a higher W. Okay, so keep this in mind. Larger the W, greater the level of prosociality. But the point of this is the amount of effort that you make, the amount of time that you spend reviewing, the amount of time that you spend doing committee work for your institute, for running these workshops and things like that. Except for a few people, it's not known to the general public. Okay, it's actually private information. The action that you take is private. But not only, the action comes from the intrinsic motivation is also private. Okay, how much I care about my students is something that you're not aware of. Maybe you can get some feel for it from the time that I spend with my students, but you might not be aware of this directly. Okay, so this is intrinsic, and it's a private variable with each individual. And it manifests itself in terms of actions. The actions is how much time I actually spend with my PhD students or my master's students. So A could be the quality of the paper, which indirectly reflects the amount of time that you might have spent. A quality of the review, which indirectly reflects the amount of time that you might have spent in coming up with that review. The why you spend that much amount of time might be because of the W. Okay, so if you don't care about this, if you don't care about, maybe you do, and if you do care about it, you spend a lot of time to ensure that you give good feedback to the author. Okay. There's some other question, I think. Yeah. So there are situations where you might not have direct proportionality with the intrinsic. It's just a model. So you may not have direct proportionality with the intrinsic motivation. Your actions may scale in a different way. Your cost may not be quadratic. Okay, so this is a very specific model just to say that you can think of these actions as coming from some intrinsic motivation. Okay, and I'm now going to get to this intrinsic motivation. Okay. So it manifests itself in terms of these actions, but often the general public don't get to know the actions that I have taken. So how much time how much time I spend with my students, maybe others don't get to see, only my students get to see it. How much time I spent on the review, definitely, most people don't say that I spent this much amount of time, but you can get the editor can get a sense from the quality of the review, and so on. So both the amount of time that you spend and of course the intrinsic motivation itself are private information. Yes. Was it you that asked the question? Yeah. Yes. This is just an example for illustration purposes. You can rescale things, etc. So don't worry about the specific nature. It's chosen so that the actions perfectly reflect the intrinsic motivation, and that's just to get the point across. Okay. Now, thankfully, there is a social norm, a prevailing social norm, that voluntarism is good. Okay, so I hope all of you agree that voluntarism is good. And if all of you agree, then there is this prevailing social norm that prosociality is good. Okay. Also, and here is the most important aspect, and this is where we deal with human nature. I care that my colleagues know that I care. Okay? And yet this particular information is lost. I care, but nobody sees that I care. So, okay? All right. So I want my colleagues to know that I care. And so what we would like to do is somehow publicize this information, leverage the social network. I want my colleagues to know that I care, okay, because I care about their opinion. I care about what they think about me. Okay? So let's leverage the social opinion and make public the actions that people have done. Okay, that the level of prosociality of the actions of individuals. Let's make that public. Okay? And this will enable me to derive a reputational benefit because I care that my colleagues know that I care. Okay? And that gives me a little extra satisfaction, and we want to make use of that. Now, of course, in the original model, where we had only, the payoff depended only on intrinsic motivation, actions, and a cost, there is no such reputation benefit. Now I'm going to bring in a reputation benefit, and I want to see how to model it. So let's see how to do this. And if I actually make this information public, the whole idea is perhaps this will make me move towards being more prosocial. So if my colleagues know that I actually spend more time with my students, maybe I'll spend even more time with my students. It might have positive feedback. Okay? Ideally, that's what we would like to do. So is this clear? Is the idea clear? Okay, so that's what we would like to go towards. And now I'm going to move towards, we already did a modeling that came from intrinsic motivation to actions. Now I want to do one more modeling that essentially takes this into account. That is, I want to somehow reflect the fact that I care about what my colleagues think about me. I want to bring that into the payoff. Okay, so let's see how to do that. Okay. So, any questions thus far? Okay. So, let's proceed further. Okay. So, I now want to model this reputation benefit. Okay. So, I said that what we will do is have somebody reveal all the actions that people have taken. So how much time a particular faculty member spends with the students, we'll try to make that public. What is the quality of the review? Okay, that's what is available with the editor. Somehow we'll put a number on it and we'll try to make it public. Okay, and so the designer who's coming, this designer is maybe the chairman of the department or the editor. He's trying to come up with what should he make public, so that people will derive a reputation benefit and as a consequence try to push themselves towards greater social actions. Okay. And so the designer, let's say for the moment, makes public all the actions that each individual has taken. So if you send me a review, I put a number to the quality of the review and I make it public. This gentleman has provided this quality on the particular review that he has sent, and so on. So for every individual, we'll make this public. Okay, and people care that others think that they have spent quite a bit of time on the review, and they derive a benefit out of that. And what's that benefit? So society is curious, and when I when everybody else in this room knows what everybody else has done as far as the quality of the review is concerned, okay, so those are the actions, then what is everybody going to do? Every individual is going to assess what is your intrinsic motivation. What is your intrinsic motivation? What is your intrinsic motivation? So society is curious and always will work to inferring a particular agent's intrinsic motivation. Okay? And of course, the intrinsic motivation can come only from the observations that society has. What observations does each of these individuals in the network have? What actions have been taken by each of the individuals? Okay? And so, knowing your quality, I am trying to assess to what extent you're intrinsically motivated towards prosociality. To what extent are you intrinsically motivated towards prosociality, and so on. And you know that society is doing this evaluation, and you can put a number to this based on this particular observation that society has. What is society's guess? Okay, and in probability, in estimation theory, one of the things that you will see in a probability class is that the best estimate in the sense of minimizing mean square error is the conditional expectation. So there is some randomness, I see some observations, and when I want to nail down what that underlying random variable is, the best thing to do is to take the conditional expectation based on whatever information I have. It's the same as saying if you have a random variable, you have no information about it. What's your best guess for this random variable? It's the expected value. That's the one which minimizes the mean square error. But if you have some information, you should take the conditional expectation. So that's exactly this particular guess of society as to where you are on the level of intrinsic prosociality. Okay. And agent I cares about what the society thinks about him. And therefore, agent I recognizes that this is where society has placed him. And so his reputational benefit is something that we will take as proportional to this. Okay, so is this idea clear to everyone? Okay, there is a guess that society has about what intrinsic, my intrinsic prosociality is if my action is AI. And of course, you get to see others' actions as well. And then this is exactly what society would guess where my intrinsic prosociality is. Now, of course, in the simple model that we had, WI was AI. And so if I told AI, what would be society's guess? The society's guess is, well, if society knows AI, then they also know the WI that I have come up with because there is equality between the two in the model. And so at first glance, it appears that there isn't much that's coming here. Society knows exactly what my WI is. There's no need for an expectation here, and so on. But then we have not taken into account that the fact that it's actually added to the payoff. So here is the payoff function. We have the original terms as before. And if you just optimize this, AI is equal to WI. But if I care about what others think about my intrinsic prosociality, and there is, let us say, a proportionality factor, how do I change my actions? Okay, so that's what we are going to study. Okay, so the payoff function, now for an individual with an intrinsic prosociality level WI, and when he takes an action AI is this. And now you see that earlier there was no interaction. If I had WI, I could decide what my AI was. I just had to go and optimize benefit minus cost across all possible actions. But now I have to think about what actions others have. Okay, and what kind of signal is being sent. And of course, I'm thinking of here the signal which is complete information about what actions people have taken. But in general, it could be different. I'll come back to that. Okay. So here are some simple observations. Here is the payoff function that takes into account the reputation factor. And I'm thinking of a very simple social network where everybody knows everybody else, okay, like in a small village or like in this particular room. Everybody knows everybody else here because you've been with each other for a few days together. And so it's a very simple social network, which is the complete network. You can also think of extensions to other networks where individual A has a local community, individual B has a local community, and there are only a few shared few nodes that are shared. But we'll think of this particular simple network. And I'm also thinking of a public announcement, that is, everybody knows exactly what level of action every individual has taken. So it's a public announcement of the actions of all. Okay, so that's revealed. Yes? Yeah, we'll come to that, because okay, so maybe I can explain it now. Think of a following, think of an example communication. So here I'm publicly announcing everybody's actions. But suppose I just indicated that the quality of this gentleman's review is greater than this threshold. The quality of this gentleman's review is greater than this threshold. That's it. Or your review's quality is greater than the threshold. Maybe my review, the quality of my review was lower than the threshold. So all that I am giving is only partial information of this sort, which is whether it exceeds or is lower than a threshold. Okay, then you have to guess. And you get to see, you have a prior on what the distribution of the intrinsic prosociality levels are. But then, based on the actual observations of the actions, but which are now quantized, you get to see only this fraction set higher, this fraction set lower. Then it will depend on what fractions say higher, what fractions say lower. Okay, what they expect, where you stand will depend on whether you're on the lower side or higher side and how many are there. That will place you in the distribution. Okay, so in general, this could depend on others' actions, and that's where the coupling happens. So it's actually a game now. Whereas earlier you could just decouple everything. Now it's networked. Is that clear, everyone? Okay, so one could of course go back to the original problem by setting the R to be 0. Then it decouples and each individual is then optimizing on his own. Okay? But when you put an R which is positive, there is a coupling that happens, and that happens through the AIs, the information that's being supplied. So there is interaction across agents and we have a game. And I'll call this the reputation game. And what we need to understand is study equilibria in this particular game. And check that this equilibrium is indeed higher. Or sometimes it can actually go lower. And when that happens, maybe the right thing to do is not to reveal this information. So, okay. So is the resulting action under equilibrium, let's call that AI star, larger than or equal to the AI. Okay, so are the goals clear? Okay, so, and it turns out that when you actually go and do the analysis, and I'll try to, the analysis is very simple. I'll try to see, if I have time at the end, I'll give you the analysis as well. Yes, people are nudged. People move towards greater prosociality. And so here is the theorem. Assume that, let's say that the intrinsic motivation distribution is some fixed F. Okay, I'll call this F. And so that F is perhaps this. So here is, that's this F, let's say. And we know that if there is no feedback, if there is no public announcement of the actions, then what you're going to see is exactly an action distribution that matches with the intrinsic levels of prosociality, which means that you get exactly this for R equal to 0. Okay, okay, there is a unique equilibrium for this induced reputation, for this reputation game. And the unique equilibrium can be expressed as follows. I can tell you exactly what each individual's actions are. If originally the player would play WI, that agent would play WI, then now he plays a slightly larger value. And of course, the value, so here is the W and here is the action. Originally, it would be along this straight line, which is the 45-degree line, so you can read it out immediately. But now there is a lift up. And of course, there are some people who don't improve their actions. If it is 0, then it is 0 after this feedback as well. This is the gentleman or person that doesn't care about society's opinion in some sense. And primarily because his intrinsic prosociality level is 0, and so maybe he's not a gentleman at all. Those would be the individuals here. But anyone, even with a slightly positive intrinsic motivation, is lifted up. Okay? but not by too much. So it's actually a continuous function. So you can plot this particular function and you'll get something like this. It has derivative infinity at, so I'll have to check that. So some derivative here, but it lifts up, okay? And then you can see that everyone apart from 0 is lifted up, but nobody is lifted up beyond R. So that's the largest that happens. And if you look at it in terms of the CDF, the one that is shifted, where everyone shifts by R is this particular CDF. So let me use the pointer, this particular CDF. But those who are here, they move only a little, but those who are already highly intrinsically motivated, they shift as much as R. Okay, so that's the theorem that one can prove. So is the result clear? Everyone is nudged towards greater prosociality. Yes? R is the same for everyone, yes. So there is a theorem to prove if R is different, if R is also distributed, there is a W and an R distribution, what is the equilibrium? So you can think about it, and maybe there can be a result that you can prove in that case. Okay, so here are some remarks. I would like to re-emphasize that it's a simple social network. I have not taken that's another direction that one could go in. It's just a network where everybody knows everybody else. And I've also assumed F is common knowledge. Okay, has that term been highlighted or told to the audience? Okay, so F is common knowledge. Okay, everybody knows that everybody knows that everybody knows that everybody knows. Ad infinitum. That the distribution is F. Okay, so that's the, yes. How is E calculated? Okay, so may I answer that question at the end? There is a technicality here, and if you're a mathematician, I have an answer to that at the very end. So just hold on to that question. We'll come to that. Okay. Now I want to bring in another issue, and the other issue is perhaps you are okay if your action is revealed to some extent, but maybe you don't want your action to be revealed completely. Perhaps your action is donation to a particular party, okay, and you may not want to reveal this information. What if the other party comes to power? So you might not want to have this revealed. And so revealing actions to all may raise privacy concerns, and so we might want to address this to some extent as well. So, okay, so here is where the other kind of feedback comes in, and this I already highlighted as sort of this quantization. So you can quantize the level of action. This is one way. There are other ways in which you can anonymize, but this is one way where you say that I'm going to publicize whether this individual action exceeds the threshold or not. Okay, so these are the people that donated more than 5 lakhs. These are the people that donated less than 5 lakhs. Okay, so I have some threshold. That threshold is 5 lakhs, and I indicate that information. Okay, but every individual, we do know whether he has donated above 5 lakhs or below 5 lakhs when I reveal this information. So society knows this. And from that, what are they trying to do? They're trying to guess what your intrinsic level of prosociality is. So in the context of donations, whether a sponsor is a diamond sponsor or not, and diamond, let's say, is 5 lakhs. Okay. Now there is a new payoff, but this new payoff, instead of the AI, it's still a conditional expectation, but the conditional expectation should depend only on what information has been revealed to society, and that's L of AI. Okay, so the levels of actions of each of these individuals quantized to the particular function that has been given. Okay, and this is also assumed to be common knowledge. And so one could ask, if I have this kind of a feedback, so this is a feedback, okay, what can we do? Now, here is an important question. So in the earlier example, I essentially said that everybody's actions is revealed publicly to all. Okay, so AI is known to everyone. And now I'm quantizing it. Of course, it serves the purpose of ensuring privacy to some extent, but not to a whole lot. I mean, I still know whether you have donated more than 5 lakhs or donated less than 5 lakhs. But you might want to know, or you might want others to know that you have given more than a certain threshold. But then there's another important question here. If I do this sort of a thing, will the general level of prosociality increase? Or will it decrease? Okay, so for example, if I give full revelation of all the actions that individuals have taken, maybe that's bad. Maybe the equilibrium action level might shift to a somewhat smaller side. Or maybe that's the best. Okay, so there is a question of what's the right information that must be revealed. In other words, one would like to optimize this L so that the overall distribution of actions is maximized, okay, or the expected action across the population is maximized. And so here we have an interesting result, which is that you shouldn't reveal everything. Yeah? So if I say that, okay, this is your review quality, there are examples where if you reveal this, you will get everybody increases. We saw that result. And there is a precise way in which everybody increases. But there is a means by which you can get the overall level of prosociality higher if you reveal less. And so it actually pays to be economical with the truth. Okay? So you shouldn't reveal all. Anyway, I'll now tell you what the equilibrium in this particular case is. So a segment, and this is also very intuitive, you will kind of relate to this as well. So here is the original action profile. Okay. What's your guess? Okay, the clue is there, but without looking at it, you should guess, you should be able to guess what might be the equilibrium. What do you think will happen? So let's take the example of those who are larger than 5 lakhs are so if you have donated more than 5 lakhs, it will be told that you have donated more than 5 lakhs. If you have donated less than 5 lakhs, you'll be told that you have donated less than 5 lakhs. So what will individuals whose intrinsic prosociality levels are at 4.99 lakhs, what would they do? They would just pay that, they would suffer that extra cost and derive a reputational benefit, because this reputational benefit is huge. When you jump a little and get to 5 lakhs, it gives society the impression that you have actually donated a lot, right? Greater than or equal to 5 lakhs. So you will donate something larger. Exactly what will you donate? 5 lakhs. And that's exactly what we see here. The action profile is there are those who have low intrinsic motivations. There's no change in their actions. So they contribute exactly what they would have contributed whether or not this revelation was there. But there is a small segment here that don't contribute the original value. So they all jump there. And then those who are above 5 lakhs, they would have anyway given above 5 lakhs. Why should they give anything more? Okay, so they would have given, they give exactly what they would have given earlier. Okay, does this make sense? It's very intuitive. Yeah, and you see this sort of jump in real life as well. Okay? And so this analysis is reflecting things that we see in practice. Okay, so the action profile for quantized feedback is, most people do those here and here do exactly what they would have done earlier, but there's a small segment just under 5 lakhs that get pushed up to 5 lakhs. And they derive a huge reputational benefit. They are faking a larger intrinsic motivation. Okay? Okay, so why did we study this? About 2-3 years back, yes. R positive, yes. So it can backfire. So there are situations where, like for example, let us say that particularly when there is uncertainty and there are contrasting motives. For example, I might give blood, but I might give blood for 2 reasons. One is that maybe so sometimes you do get a reward for, you do get a monetary benefit for donating blood. And so there is that. And then there is also the other thing, you give blood because you feel that that's a contribution that you need to make, that you're intrinsically motivated. Now, when there's uncertainty about what is my monetary need, so you think of that as one axis, and there is uncertainty about my intrinsic prosociality. I would like everyone to think that I have high intrinsic prosociality, but if I give more blood, society may think that maybe I don't have enough money, that's why I'm giving blood. This person is volunteering a lot because he wants to become the next chairman of the department. Okay, so there is this kind of backfiring that could happen. So when that happens, then you actually see when a monetary reward is announced for giving blood, the number of blood donations go down. So there are interesting things like this. Okay, I'll come to that in the end. So it is not a situation where R is negative, but I'm just saying that the example that we had is a very simplistic model just to bring out some ideas, and one must actually think of, when you're thinking of giving monetary benefits, you should think of these contrasting objectives or motives as well. Okay, so why did we think about this? About a couple of years back, I think since about 2015 to about 2017, we ran 1 year, it was actually a 14-month program where we tried to give feedback to consumers on what was their consumption. And so this was an experiment that we ran in Cochin, close to Cochin, in a town called Alua, which is a suburb of Cochin. And we had about 40,000 households, and we wanted to see how people reacted in that particular situation. But what I'll give, so that's what got us thinking about this. What kind of feedback should we give? And the kind of feedback that we gave was, we wanted to make people, we wanted to exploit that going green is good. And people think that if others think that they are going green, then there is an increased reputational benefit there. So how could one leverage this? But particularly what we were interested in is we wanted to find out what are the right signals to give. What's the L that we should choose? Because one of the things that was noticed in earlier experiments is that if you tell those who are lower consumers, consuming less is costly. You have to suffer in Cochin the hot and sweltering heat if you don't turn on your AC. Okay, but you would do this if you get a good benefit, reputational benefit. But if you're anyway getting that reputational benefit, and let's say you're below the average, there are others that are consuming a lot more, then why not turn the AC on a little bit and be a little more comfortable? So actually this kind of feedback, when you give to individuals, it could bump up the consumption. So we wanted to check what's the right feedback to give. And we had some intuition that those who are below the average, let's say you're in the better third. Okay, so you can think of quantile feedback that you're giving, and we say that you're in the best 1/3. Okay, so they are consumers in the bottom 1/3. They are consuming less. So we give them feedback of this sort. But when you give them this feedback and say that this is your exact percentile, then they may tend to relax and they may consume more. On the other hand, if you say that you're in the good 1/3, then most people tend to assume that they are on the threshold. And they might continue to save energy as they've been saving before. And so we wanted to find out what the right signals are. What should we give to those who are above the average, those who are in the 1/3 to 1/2, and so on. And that's what got us thinking about this and modeling it and trying to figure out what the right answer is. And we still don't know what the... so this one gives us some overall reputational benefit for the entire population. The other one gives the full feedback something. We still don't know what the optimal L is. And for the game theorists here, we have an optimal, not mechanism design, but information design. Okay. So motivation is exactly this. Here is an experiment that somebody else conducted, which is a little more closer, which is a little closer to the specific model that we had. There was a small community of test households. This was done sometime in 2008. At the end of each month, there was a green sticker which was placed on the doors of households with consumption below a certain threshold. So those who consumed less, there was a green sticker. Oh, this is a green house. Okay? So they consume less, they're going green. And those who consume more than this threshold, there was no sticker in their homes. And this is something that everybody could see. It's like the threshold feedback that I came up with. And the goal is to essentially explain equilibrium behavior in this case and also figure out, is this the right feedback to give? Threshold, is this green sticker the right thing to give? Maybe you should give some rewards, maybe you should give some additional feedback, say a little more about the consumption of this individual. What's the right information design? So that's something that we don't have an answer to yet. Okay, so that's the need for information design. Okay, I'll now, I have about 5 minutes in the 1 hour that I've been given. I'll just give you an idea of the proof, how to get to this equilibrium, because I think it might be something that you might use in other settings as well. But it's a little more non-trivial compared to, it's a little more difficult, conceptually difficult than the ones that you might have seen, the notion of a Nash equilibrium in a finite game. Okay, and that's primarily because of this particular object. And I'll return to answer your question as well. Okay, so recall that this is the payoff. Okay, and let's, for the moment, okay, let's also recall the theorem. So what's the theorem? Every individual gets pushed up a little bit. Okay, and so this is the theorem that we want to prove, that the level of prosociality is of this form. Excuse me. So here's the payoff. So let's write this conditional expectation as something that depends only on the AI. Okay, so this may or may not be true, but let us search for equilibria where that's the case. That means that if your action is AI, and that's revealed to all, let's search for equilibria where the conditional expectation is this function, x of AI. Okay, and we need to search for that function. And so that's what I call x of AI. Okay, if you solve under this condition, that doesn't mean that you have captured all the equilibria, but you might have captured some equilibrium. Okay, so when you put this as a function of AI, it's a reputational benefit that depends only on the AI, and therefore the action taker can do an optimization based on this x. The only problem is this x is unknown, and we have to search for this function. Okay, and so if you take the derivative and set it equal to 0, and of course we must make sure that it satisfies the second order condition also, so that it's a minimum. That's something we need to check as well. But let's just do the first order optimality for now. What does the first order optimality give? So take the derivative of this, what's that? That's Wi. Take the derivative of this, what is that? That's AI. So Wi minus AI, so I'll take it to the other side. I'm going to equate it to 0, so I'll take it to the other side. And then what's the derivative of this? It's R times X prime of AI. Okay, and so that's, when I take it to the other side, it's minus R X prime of AI. Okay, so this is what I have. And let us also look for equilibria where this function is monotone in the AI. If it is monotone in the AI, I can, from the AI, invert and get the Wi. So if I have a monotone function, from the value you can tell what the value, from the output, you can tell what the input is to that function. So from the value here, you can, which is AI, so you know the AI, and let's say this is what I'm looking for, and I can get the Wi. Okay, so if it is monotone, I can invert the AI. And if I can invert this, I can get the Wi. Okay, so that's what we'll make use of. So Wi can be inferred from the AI. Okay, and hence we can write, so if I can infer the Wi is just this x of AI. Right? If I can infer the Wi, there is no uncertainty in the Wi. So expected value of Wi, given all the other actions, is exactly Wi. If I can invert it, I know the Wi. So I can actually say that this conditional expectation is just the Wi. So this is the conditional expectation. I know now what it is perfectly from the observations and the particular action that an individual has taken. So I write that as xi. So that's this formula, recognizing that it's just Wi. And so xi, which is Wi, is just AI minus xi prime of AI. Okay, that's a differential equation in AI. I'll just solve for it. And you can solve it. It's a simple differential equation. We need to add a boundary condition. What's the boundary condition? The person that has intrinsic motivation 0, you will recognize from the conditions that his action will also be 0. Okay, and that's something that's easy to see, because if he does any positive action, he actually is going to derive, this will be he has a wi of 0, that wi is completely revealed, and therefore this is also 0. And any positive action that he takes, he derives no benefit. This is 0, but he incurs a cost, which is minus half ai squared. And so he will choose ai equal to 0. So the boundary condition is ai equal to 0, wi equal to 0 implies ai equal to 0. So you do that, plug that in, solve this differential equation, and you get this. Okay. That's a good place to stop. I need to answer your question. So there's a proof idea for the next one also. I will not dwell on it. So just to conclude, we exploited social norms to get immediate improvement in the action profile. And going beyond this opens possibilities to use information feedback to get a collective identity, to create collective awareness. So you can use this in rather powerful ways. Okay, so I will stop here. I'll take some questions and then I'll come back to answer your specific question. Okay. Now, if there are no other questions, I'll come back to answer your question. So how do you evaluate this conditional expectation, right? Was that your question? Okay. So I'll answer that question in a non-rigorous way, and then I'll come back to answering it in a rigorous way. The non-rigorous way is something like this. If you take the second example, there you see that maybe I am an individual that donated more than theta, the threshold, and others donated a certain amount. And so there is an original distribution, and then there is a mapping that I have from the original distribution to actions. But if this is the fraction that have donated larger than theta, then I go back to look at the conditional expectation. Okay, so that's the conditional expectation that you need to evaluate. And that will depend on a belief. The society then thinks of, so the way you solve this is, there is an action and there is a belief that society has about the action. And the conditional expectation is based on the belief. And these must match at equilibrium. Okay, so that's the fixed point that you're speaking about. So the conditional expectation is always taken with respect to some belief. If the action profile matches with that belief, so for example, let's say that the society assumes that this is the action profile. That's the belief. And from that, they will come up with an estimation of what the W is. So let's say that based on that, there is a reputational benefit, and the reputational benefit will determine the actions. If those actions lead to a certain action profile which matches with what the society believes, then there is a match, and that's the equilibrium. So that's exactly what we look for. So that's the way you'd go and solve this particular problem. Okay, so how they affect. Exactly, that's the key point that we need to take into account, that each of these players is taking into account in trying to come up with what action he has to take. So he's taking into account what society would believe his particular action is with respect to the general profile of actions of others. And he computes what society would compute, and then he derives the reputational benefit, and he tries to optimize it. So there is a best response for society's belief of the actions, the action profile, and this action profile must match society's response. That's the equilibrium calculation. I hope I have answered that question. There is actually a mathematical issue here, and okay, so I'll just indicate what the mathematical issue is. I assumed a continuum of individuals distributed between 0 and 1. And I had a Wi which was independent and identically distributed, sampled according to this particular distribution. There's no such, the only such thing that you can have is the constant. Okay? And so there is a mathematical gap that you need to fix. And there is a way to think about this. And in fact, there are two ways. One is to view society as, so there is one principal player, and then there is an agent. and society is the agent, and society is responding with an estimate of what this individual's intrinsic motivation is. That's one way, and then you look for a Bayesian Nash equilibrium. There's some, I don't know if you have covered that. So that is one way to fix this issue. And then there is another more rigorous limit way to fix this issue. And that's something which is an open problem that people can think about. But there's what is called a Bayesian Nash equilibrium, signaling equilibrium that one can think of here. That fixes the mathematical issues. Okay, so that's for the students who are a little more, who have a little more background in mathematics and measure theory and related topics. I think this is a good place to stop. So, thank you.